yesterday we were kind of we were going pretty quickly through our notes, trying to get as much done as possible so you could get to the homework. So let's just go back here for a second. Let's make sure we're clear on the concept of density, how we calculate it, different steps you might take. And then we'll talk a little bit about how heat affects density and how density affects buoyancy. And then we'll be done with our notes. We'll be ready to start our lab probably tomorrow. All right, so we already went over this. So we did this one super fast. So let's just make sure, guys. So let's make sure we understand how to do this correctly. When you are calculating density, it's basically just you need to follow two steps. So we already talked about how we find the volume of objects. Okay, so that's one part of calculating density. You have to find the volume using either water displacement, using a formula. Somehow you find the volume of the object. Then you use a valence to find the mass of the object, and then divide to find the density. So if you break the problem up into those steps, then it should be pretty clear how to find the density. So we have our formula, and when you're solving these problems, as we did in volume, I want you to show the steps. So you write the formula, substitute in proper numbers, and solve it. So here we have two steps we have to follow. First, we need to figure out the volume of this cylinder. As we learned, to find the volume of a regular shaped object, we use a formula. We measure the dimensions, and then we use the formula. So the formula, the volume of the cylinder, pi r squared times height. Substitute in our numbers, we use 3.14 for pi. The radius of this cylinder is 1.5 centimeters. The height of the cylinder is 7 centimeters. Do our math, we have 49.5 cubic centimeters of the volume. So, it's a ratio. It's a ratio of the circumference of a circle to its diameter. That's what I think where pi originally is. All right, so then I have my volume. I was already given the mass. So if I divide mass by volume again, substitute in, I get my answer with units. So density of this is 10.5 grams per cubic centimeter. So what is it made out of? Raise your hand if you could tell me what substance might this be? Raise your hand, please. Silver. It's silver. Silver, if we look at our density chart, has a density of 10.5 grams per cubic centimeter. So, as we said yesterday, density is an identifying property. By looking at the density of an object, it can help us to figure out what it's made out of. Okay, you guys do this one. So I'll give you a couple minutes. I want you to solve and determine the density of this object. Okay, so if we first start, I need the volume of this rectangular solid. I write the formula. So here it's combined in one formula. So the density is the mass, 770 grams, divided by the volume. The dimensions on this shape, 15 centimeters by 5 centimeters by 6 centimeters. Give me 770 grams divided by 450 centimeters cubed for a density of, who got an answer? Jake, what'd you get? You, Jake. 1.7 veggie burgers with brioche buns and cheddar cheese. Ketchup. Go ahead, Jake. Yes, grams per centimeter cube. So, yes, you could separately just find the volume and then plug into the formula. That's fine. Yeah, typically I'm going to ask you to round to your tens. All right, what element is this, Danielle?
Magnesium.
Magnesium, yes.
I'm a genius.
Yeah, so
All density
is what?
all density.
Well, density is one identifying property, is the best way to say it. So density is a property that can be used, and we're going to talk about this in our lab tomorrow, along with some common sense and some research to help you identify amounts. Because the reality is, most substances that you have in real life are not pure substances. So they may have other materials mixed in with a single element. There could be different compositions of different materials. So often you're going to find the density and find it doesn't quite match anything exactly. But if you know a little bit about it, what it looks like, if you do a little research, use some common sense, you can usually figure out exactly what element you have. Now, heat does affect density. What did we say happens as an object gets heated? What? Yes, and it expands, and therefore its density decreases, right? The molecules are getting less spread out because they're expanding, its density is decreasing. So heat expands objects, which increases their volume, which decreases their density. Because the mass doesn't change. As you heat up an object, does its mass change? No. Here's our density chart. So what you have here, and you're going to be using this in the lab that we work on tomorrow and Thursday. You have solids, liquids, gases. But again, this tells you at a certain temperature. Because obviously if the temperature is different, the density is different. So the solids, it's telling you what their typical density is at 20 degrees Celsius. Okay? That's like room temperature. That's like 65, 68 degrees. Same thing with liquids. And then gases, it's telling you at 0 degrees Celsius. Okay? So what do you notice about, do you notice a pattern of densities of solids, liquids, and gases? Raise your hand if you look at that and have an idea. Danielle? Yeah. Tell me more about the pattern of numbers. Devin? Oh, let me. You have an observation first. What? Okay, the ranked greatest to least. Jake, what else? All of them. Okay. Caitlin? Okay. How about if we compare gases, liquids, and solids? Maddie? Yes, overall, the solids are the most dense. What's the least dense? Gases. It's not perfect though. Like are there any? So we're going to talk in a minute about certain in a liquid or a gas, a less dense object will float. So is there anything that floats on water? No. Jake?
Pine wood, balsa wood.
Yeah, pine and balsa wood placed in water would float because their density is less than water. Is there any way you could have a block of steel float in a liquid? A block of steel
Yes.
floating?
Liquid has greater density temperature.
Why?
No.
Couldn't heat it up, it would melt. Is there an example of that, Mitchell?
Mercury.
So look at mercury up there. Mercury, the most dense liquid. Mercury has a density of 13.6. So you could float steel, copper, silver, lead, even a block of lead would float in mercury. It's sort of crazy to think about. Because mercury is a very, very dense substance. And we'll talk more about this in a minute. All right. So buoyancy is this concept that this force that keeps objects afloat. And as we said, objects with lower density float, and liquids or gases of higher density.
Wait, so why can we float if we are? It can.
It can.
It can.
Hold on.
Actually, both can float, right?
We'll talk about that. We have one activity, maybe we'll get to it, which will answer that question. All right. So, not only will less dense objects float in more dense objects, but their density will determine how high or how low they float. So, if you have, so the density of water is what? 1 gram per cubic centimeter. If you have an object that has a density of 0.5 grams per cubic centimeter, it will float so that exactly half of it is above the water and half is below the water. What if you had something with a density of 0.1 grams per cubic centimeter? Yeah, it'd be floating very, very high on the surface of the water because it has a very low density. What if you had an object that's 0.95 grams per cubic centimeter? Yeah, it's going to be almost completely sunken in the water with just a small portion above the water. So the density difference also determines how high or how low something floats. So this is a person in a liquid floating on mercury. No. So, as I just said, mercury is so dense of a liquid that this guy is basically sitting on top of the mercury because there's such a big difference between his density and mercury.
Hope he doesn't.
So, here is the thing about mercury. It's toxic. So liquid mercury is actually the least toxic version of mercury there is. Gaseous mercury is very dangerous. But mercury is no longer, so we used to have mercury thermometers in school. It's in thermometers, a very tiny amount, but it is in them, and we are no longer allowed to use them. Mercury, I used to have this bottle about this big and this big of just mercury, and I had it in like 2 plastic bags, and I used to pass it around because you could hold it, you could feel super heavy for this small amount of mercury. No, it is not. That's not a good idea. I would get in trouble. So I know of another teacher in their school. One of their students, her father worked in some industry, and they use mercury, or used to use it more often, and had a big container of mercury. And mercury is weird because if you put it in your hand, it sort of forms balls. You can roll it around your hand. Well, this kid brought it into the school and gave some of it to all his friends. They're all playing with it and stuff. They actually had to shut down the school for months while they cleaned up the mercury. Because they didn't really know, they thought it was cool rolling around their head, and they realized that it's a toxin. Yeah, I don't know the exact story, but yeah. They got in trouble. They're like junior high kids. So if you you can also layer liquids and solids of different densities, and they will separate out. Here I have 3 liquids of different densities. These layers. Here's another example. All of these objects have different densities. You have dish soap, which is the most. Yeah, like oil and water, but which one's always on top? Oil's on the top. They just colored it so you can see. Like here, I have my salad dressing I use every day. Okay. And you can see I have oil is on top. The vinegar's on the bottom. That's why people always say it smells vinegar in here when they come in afterwards. And yeah, so that's separated out. And then there's some solids. Those are my Simeon seasonings I put in there too. So
Can you shake it?
I could shake it and it'll mix, but then what happens? It'll separate back out according to density. Also because of the properties of lipids versus water soluble. If you do this, if you put a can of diet soda and a can of regular soda in water, the regular soda will sink. Why? You tell me.
Because it's diet.
What's the, so why would they be different? Danielle? Sort of. So they have the same volume, right? They're both the exact same volume, but they have different masses because the Coca-Cola regular is made with regular. What's Diet Coke made with? Artificial. So, but there's still something in there. But have you ever used artificial sweeteners?
Yes.
Do you put like the same volume in as sugar? No, you put like a very small amount. It's very sweet. So there's less of that in here, giving it a lower density. So, Indiana Jones. You guys seen Raiders of the Lost Ark?
Yeah.
I want you to think about this little sequence we'll watch, and I want you to consider density as we do that.
I know what he did wrong. He that's so.
Indiana Jones made.
He put sand on the thing.
What do you know about the density of gold? It's very dense. What was he seeming to like estimate when he had his bag of sand? Well,
The size.
he was more trying to approximate the volume of the idol and replace it. But that gold statue would be very, very heavy, okay? Because gold's very dense. Like he'd have a hard time holding it in his hand and running, not just carry it with one hand like that. He'd have to have a huge bag of sand to have the same mass as that gold idol. So he didn't take density into account.